Additional topics. Now in this subset of SAT Math, we're going to talk about some of these topics that SAT writers deemed additional. This is not my term, but they have decided that geometry, trigonometry, some of these other word problems are going to be something you can leave for the last. I think it's okay, and I'll show you some of these problems. However, I would also recommend that you start looking at some of the probability questions, as they tend to be some of the most difficult ones for international students. So let us just go first into a quick overview of probability, and then we'll move on to the additional topics from this section. So first of all, I wanted to rehash some of the key skills that you will need to possess in order to solve the probability problems. Key skill number 1, you will always need to remember that you are ultimately trying to compose a fraction for your probability. And on the numerator, on top, you will have your number of desired outcomes. And on the bottom, in your denominator, you will have the number of all outcomes. For example, we have 4 green marbles and 6 blue marbles in the bag. What is the probability that we had the green one if we just close our eyes and pull one out? Of course, it would be 4 green, which would be on top in your numerator, over 10, which is the total number of marbles in the bag. Now that seems easy enough. So let's actually take a look at sample problem 1 that has a harder concept here in store for you. Young Jim has bought a ticket from Lucky's Lottery hoping to win the July jackpot. For a payment of $100, he gets to play 5 numbers between 1 and 100. For each even perfect square that he scratches, he gets $20 back, and for each perfect cube, he gets $40 back. While for all other numbers, he gets nothing. As young Jim starts scratching, the first 4 numbers that come out are 3, 16, 9, and 81. What are the chances that Jim would at least recover his initial investment after scratching out the final number? And then in the answer choices, we have a few fractions here. In order to answer this question, you would first actually need to know the mathematical term for what a perfect square and a perfect cube is. I will give you a hint. So perfect square is actually squares of whole number. So that might be 1, 4, 9, and so forth. So you should think about what a perfect cube might be. This is a related terms. And then think about how many of those you might have between 1 and 100, since that is what our Jim is scratching, and what would be the number of the desired outcomes here. Let's move on to key skill number 2, also in probability. So here we'll think about the situation when order matters. So there are several events happening at the same time. So typically, let's just imagine that we again have 10 marbles in the bag and 4 out of them are green. So the probability of taking out the first green marble is 4 over 10. You know this already. But now what if afterwards you decide to pull out one more? The key issue to remember here is that now you no longer have 10 marbles in the bag, but now there are only 9. So your denominator, the bottom of your fraction here, is changing. Now, some problems will say that you're pulling this out at the same time, and here this also applies. So when you calculate the probability of the second event, you can assume that 1 has been taken out, unless you're told that it was replaced. So let's take a look at sample problem 2. Bobby knows that he has B blue marbles and G green marbles hidden away in Granny's flower pot. If while searching for her glasses, Granny rummages through the pot and takes out 2 marbles without looking, what is the probability that both of them are blue at the same time? So here, these events are dependent, so one of them influences the other one. This happens because she already took 1 marble and the probability of the second marble is influenced by this first event. So as you create one of these fractions that you have here as possible answer choices, so just think about what happens after one of them is taken out and try to write out their probabilities separately from each other. Now let's talk about the next key skill, where I want to talk about events that might be happening independently of each other. So let's say I continue to try my luck with the same marbles, right? So I have this bag where we have 10 of them, and then I'm trying to pull out the blue one, right? But also I am trying to throw the coin. So what is the possibility that both my coin will give me a lucky heads and my marble will be green? Here, first I would need to calculate the probability of these independent events. So for the marble, it's 4/10, and for the coin, it's 1/2, and then I would need to multiply these probabilities. And if the events are dependent, then their probability would have to be summarized. So let's take a look at some of the problems here that can also help us understand this concept. So here in sample problem number 3, we have a fair die that is thrown 3 times. Okay? And just think about how the fair die, whatever happens with next time, does not depend on the previous time. So what is the probability that 5 will come up exactly 2 times? And then we have 5/216, 5/72, and some of the other answer choices here. So in addition to thinking of those independent events, you also need to think about whether the order matters here. So for example, let's say we have 5, and then we have some other number, and 5 again. Is that the same as having 5, 5, and then some other number here? So just think about how would you deal with these problems every single time, and do not get confused by a lot of words. A couple more. Sample problem number 4. At a barbecue, all the guests decide to toast each other. And to be polite, everyone decides to click glasses with one other guest present at the party individually with each other guests. Now, if we have 78 clicks of the glasses that are exchanged, how many people are gathered at the barbecue? 10, 11, 12, or 13? In order to answer this problem, you need to think about how people toast each other. So if I toast you, that means that this toast has taken place between these 2 people. So how many more people do I have left to toast? And then the person that goes after me, he has already toasted me. How many more people does he have to go over? So you can solve this from the final number of people at the party that you know to be 78. So try to come up with the equation and then find your initial n. Next problem. Sample problem number 5 will actually be mixing geometry and probability here. Robin's Hood Carnival Challenge consists in the player using a medieval bow to shoot an arrow at a circular target hanged in a tree. The target has a dark outer ring and a golden inner disc. If a player hits the inner disc, the king awards him $90, while hitting the dark ring means the player must pay the sheriff $45. If he misses the target altogether, he's just forgiven on the grounds of inaptitude. If the ratio of the radius of the smaller circle to that of the whole target is 1 to 3, which of the following should the brave archer expect as a reward? So here you'll need to remember that the whole probability is 1. So what does that mean for the sum of probabilities that you would have in the yellow disk and in the dark circle combined? And then you also are given the relationship of the radius of the 2 disks in the problem. So think about what that means for the possibilities that our archer ultimately has. Now that we have talked about the probability problems, and of course there are many more, and we're just giving those to you as samples, I want to switch gears and talk a little bit more about geometry. Now the main thing here is you have likely seen most of those in your high school program already. Now just do not be afraid of the confusingly worded questions that you might see on SAT. Also, you will get the sheet that will be listing key formulas and relationships, so you do not necessarily need to be remembering all of them. Just take a look at what will be given to you on the test, and whenever you do the test, try to have it. Finally, remember that all the problems will be drawn to scale, unless indicated otherwise. So let's take a look. In sample problem 6, you have to find the perimeter of the red square, so the small inner square, in terms of A, in terms of the diagonals. And just notice that the area of the red square is the same as the shaded area. This looks complicated. However, you just need to remember that the squares are basically 2 right triangles, right? That are just there together, that are separated by a diagonal. So then you can either use the Pythagorean theorem, that hopefully you know, or some of the relationships of the 45, 45, and 90 triangles, which are ultimately the triangles that compose the 2 squares. You can also remember the formula for the perimeter of the square and for area of the square. They're ultimately going to be useful as you go here and work out the relationship to the 2 square. Sample problem 7. Queen's gardener decides to make the finest geometrically perfect garden in the kingdom. He's planning to alternate white roses and green plants in concentric circles, such as the distance between circles would always be equal to the radius of the first white flower bed in the very middle. What is the relative proportion of the area covered with white roses to the overall garden area? To solve this problem, what you need to think about is think of relative areas of each circles that you have and think about how you can express them perhaps in terms of each other. And then, and this is important for many, make sure that you actually read this question carefully to see what the fraction is ultimately required to be calculated. You will always have a trap here in the answers, so please go ahead, calculate all of the areas and see which one would come out to be correct. And finally, let's talk about sample problem 8 with complex numbers. Now it sounds so complex, and I know that this is the last problem that we'll see here in the mathematics subsection, but honestly it's not that complex. So what's the value of this complex number expressed here? Now as you start to look at this I thing, all that you need to remember is that this is essentially just square root of -1. So it's just a mathematical representation of this expression. And all you need to do is essentially just treat it as a variable in itself and try to get a square root here. So in general, for SAT, you would want to be remembering the list of various numbers and the English terms for what they stand for if your primary language of instruction has been other than English. So please make sure every single time when you see some other mathematical concept, just make sure to jot this down so that it would not present the problem to you on the real test.